Morning, Chargers, or afternoon, or evening, whenever it is that you're watching this lovely video. This is Mrs. Boyd going over section 8.8 from Algebra 1B about differences of squares. What we're looking for here is the easiest way to factor a polynomial with two perfect squares and a minus between them. So let's look at example 1. We've got 16h squared minus 9a squared. Well, 16h squared is a perfect square. That is 16. The square root of 16 is 4. The square root of h squared is h. Now, 9a squared is also a perfect square. Square root of 9 is 3. Square root of a squared is a. To make this easy, we're going to make two parentheses, a plus and 1, a minus and 1. The square root of your first term at the beginning of each of these, the square root of the second term at the end. That's it. If you know your squares, then you're going to be set. If not, we're going to have some practice. Next one, 121 is a perfect square. Square root of 121 is 11. Square root of 4 is 2. Square root of b squared is b. So we're going to need two parentheses, a plus in the middle of one, a minus in the middle of the other one, 11 in the front of each, 2b on the back end of each. Now, we look at the next one, you're thinking, oh, 27g cubed. None of that is a perfect square. Well, first, we're going to have to factor something out. I can divide both of these terms by 3. I can also take out a g. Now I'm left with 9g squared minus 1. Well, 9g is a perfect square. It's 3g. 9g squared is a perfect square. It's 3g. 1's a perfect square. It's 1. So my 3g has to tag along. Two parentheses, plus in the middle of 1, minus in the middle of 1, 3g in each beginning, 1 on the end. And we've done it. Okay, try the next one on your own and come back and check your work. All right, so 81 is a perfect square. Square root of 81 is 9. Square root of c squared is c. Two parentheses, 9 at the front of each, opposite signs, c on the back. Try the next one. Come on back. Okay, 64 is a perfect square. It's 8. Square root of g squared is g. Square root of h squared is h. So, two parentheses, plus in the middle, minus in the middle. I haven't said this yet, but it bears saying. It doesn't matter where the plus or minus is. Okay, you can put the minus at front and the plus in the back if you want. So 8g in the beginning, h at the end, and we've done it. One more, try this one, and we'll be all done with that. All right, so x cubed is not a perfect square, but if I factor x out of both of these terms and get 9x squared minus 4, now I've got perfect squares. Square root of 9 is 3, x squared is x, square root of 4 is 2. So x tags along out front, two parentheses, 1 plus, 1 minus, 3x at the front, 2 at the back. All right, I hope you get that. We blew through it pretty fast. Now we're going to look at some polynomials that require a little bit extra factoring. B to the fourth is a perfect square. B squared is the square root of b to the fourth. And 16 is a perfect square. That's 4. So we need two parentheses, a plus and 1, a minus and 1, b squared in the fronts, 4 in the backs. Now, the first one we can't do anything else with, but the last one is the difference of two squares again. B squared, square root is b, 4 is 2. So b squared plus 4 is going to stay. B squared minus 4, we're going to factor again and have b and 2. And that's it. We've done it. Try the next one on your own. Ready, set, go. All right, let's scoop this up here. All right, Last one. You look at 625 and you think, huh, I'm sure that is not a perfect square. Well, I have some news for you. It totally is. The square root of 625 is 25. Whoopsie, so sorry. Square root of x to the fourth is x squared. X squared times x squared is x to the fourth. So 2 parentheses, plus and 1, minus and 1, 25 goes in the front, x squared goes in the back. And just like above, 25 plus x squared we can't do anything with, minus x squared we can, because square root of 25 is 5. The square root of x squared is x. So 25 plus x squared just stays where it's at. Then we have 2 parentheses, a plus in one, a minus in the other. Now 5 goes in the front and x goes in the back. Very nice. Moving on, we're going to factor just a little bit more. We've got 5x to the fifth minus 45x. So I can factor 5 out and I can factor x out. That means I'm left with x to the fourth minus 9. Well, here we are again. X to the fourth is a perfect square. That's x squared. 9's a perfect square. That's 3. So 5x is going to stay. 2 parentheses, plus and 1, minus and 1, x squared on the front, 3 on the back. Now, you might want to take this x squared minus 3 and do some more with it, but we can't because 3 is not a perfect square. That's as good as it gets. Last but not least, we're not going to do that bottom one, I don't think. We have 4 terms here. We can't factor out anything out of each of them, so we're going to use factor by grouping. I'm going to group the first 2 together and the last 2. What can I take out of the first 2, you ask? Well, that looks like a 7 and an x squared. That makes me left with x plus 3. On the last one, I can factor out, looks like -7 and get x plus 3. So the identical stuff inside is one factor. Everything outside is another. Well, if I look at the 7x squared minus 7, I can factor a 7 out. So this is 7 now, x plus 3, x squared minus 1. Again, x squared minus 1 is the difference of 2 squares. The square root of x is squared is x. Square root of 1 is 1. So I've got 7 and x plus 3, and then 2 parentheses, plus and 1, minus in another, x in the front, 1 in the back. Looks like it. We're going to skip number 4 there, and that'll be it. Okay, good luck, guys. Let me know if you need any help. I'm here if you need me. Pause and go back and re-listen as many times as you need. Good luck, and I'll talk to you soon.